Hello, everybody. I'm going to talk about non-terrestrial network in 6G context. This presentation prepared with my colleagues. I'm the technical manager of this project, which aims at developing NTN component fully integrated in 6G infrastructure to support enhanced mobile broadband, but also quasi-ultra-reliable low latency services for vertical and consumers. It's a 3 years project. I'd like to first talk about the ambition of 6G NTN with respect to the NTN component of 5G. So we have a number of ambitions, which is in the area of user experience. We want to obviously increase the data rate that can be offered to users, to increase the reliability, to extend the coverage to light indoor and in-car areas, to increase the location reliability and accuracy, as well as reduce latency. But also on the other side, in terms of network capabilities, we believe that the NTN component can contribute to the overall resiliency of the 6G system. Maybe there is going to be benefit for spectrum sharing between NTN and NTN in order to optimize the spectrum usage in certain spectrum, not all. Also, it could contribute to reduce the footprint, especially the energy saving of the overall network. And there are going to be some kind of multi-orbit, multi-layer network with satellite at different altitude and all interconnected. So this will create and set some big challenges in terms of security with all these network nodes flying. We have to obviously improve the capacity and connection density capability. Another feature which is very important is to be able to operate without the GNSS, especially indoor, because the GNSS will not be able to reach indoor. And there are some other features like fast network deployment. That's something the NTN can contribute to provide, especially for disaster relief. As part of the project, we are not addressing yet the integrated communication and sensing, but this is something that could be of interest in the NTN context, especially to monitor macro phenomenon, meteorological conditions, in conjunction with some specific and special purposed meteorological space segment. We want to have a user-centric with the 6G NTN, so to be able to carefully design the terminals that will be adapted to the installation and the operational constraints, especially on board vehicles and drones, which is going to set a lot of challenges in terms of interference mitigation. But that could be of benefit for all verticals. And last, it has to interoperate with the 5G and possibly support multi-connectivity at RAN level, because in 5G it's more at core network level. And this could help the seamless mobility between NTN and TN to mitigate the potential holes in the terrestrial coverage that may occur. We have worked on a number of use cases, which are basically addressing the connecting of the unconnected usage scenarios and the security and resilience. This is mostly the added value of NTN within the 6G. There are going to be a potential improved user experience and features that we would like to promote as part of the SA1 study items that is like to start later this year at SA1 level, which are in direct relation to the use case and the ambitions. Obviously, there is an interest in the support of emergency services in light, indoor, in-car conditions, the provision of trusted, accurate UE location, so much more accurate than in 5G. We are considering to enhance the bandwidth for consumer handheld, targeting to video. In-car and light indoor is going to be limited to emergency services, basically. But we want to still improve the bandwidth for handheld, whereas today is very much limited in terms of data services within 5G. We are also considering to provide broadband connectivity to cars and drones. This is in line with the ambitions. And this will require, we said we're going to especially carefully design the terminals adapted to drones and vehicles, and this will require to define new types of terminals in the relevant frequency band. And in terms of network capabilities, at SA1 we will work on autonomous network, since NTN may not be permanently connected to core network. So we have to find ways to autonomously operate the NTN network. Energy efficient service delivery, we're working on that. We're proposing some metrics that we think could be valuable to compare with the metrics of the terrestrial network. The flexible spectrum usage will require to have some coexistence between NTN and NTN, as already said. The HUT resiliency, which is desired because increasingly the mobile system is at the basis of the digital economy and at the economy at large, and therefore resiliency should be a very important target for 6G, and NTN can contribute, not having the same capacity obviously as the terrestrial network, but can provide some additional links, so redundancy, hot redundancy, in order to increase the overall resiliency of the network. But this will require some very smart routing techniques to route the traffic via the 3D NTN network, but also between the NTN and NTN. Okay, this is a table that I don't think I'm going to go through in detail. We're targeting some improvement in terms of performance, and they are highlighted there. I will distribute the slides so you will have the possibility to look them. When you compare with the optical fiber, definitely you're not going to get the same service rate performance, but we believe the NTN component is more for coverage and improved resiliency. There are a number of design drivers that we're considering. So a multi-layered architecture with internode links, both RF and optical based. So the optical links are going to be adopted between satellite at same orbit, same altitude, whereas we would adopt RF-based link across different orbits, so especially between GSO and non-GSO. We are working on an innovative LEO constellation design that takes into account the high constraints of satellite in terms of size, weight, and power. We believe that all satellite, but not only satellite, HAPS and drones that are going to form this 3D multi-layer architecture are going to embark software-defined payloads that may embed RAN and possibly some core network functionalities, as well as edge computing resources. We need to make sure that the access protocol can support multi-connectivity between different frequency band in which the space segment is going to operate, especially for drone and vehicle-mounted terminals. Because initially, there is an interest to provide connectivity in FR1 bands, but that's going to be limited in terms of service rate. And there could be an interest to add connectivity in higher bands and combine both, because the higher bands are feature less service availability compared to the FR1 bands. The fact that we have going to use very small devices, small terminals, will create huge interference issues, because the terminal are going to broadcast basically towards many neighboring satellite or hubs compared to the serving one. And this has to be mitigated through AI-driven radio resource management techniques. I think I've already talked about the security issues. There's going to be a dynamic orchestration of VNF that are spreaded across the 3D architecture. And I've talked about the energy consumption and carbon footprint constraints. And we definitely need to define, to agree across the 6G projects on common metrics. So this is the 3D network concept I was talking about. So NTN covers geostationary satellite, non-geostationary satellite, hubs, as well as drones, whereas drones could be embarking network node or user equipment, especially if you have a drone which is monitoring something on the Earth, then it would be equipped with the user equipment on board. But also the drone could be served as a network node. If we're talking about NTN as a native component, then we are considering to enhance further the 5G NR radio interface to be more satellite friendly. And enhancement that we are considering are to enable relaxed synchronization requirements, to be less dependent on GNSS, but also to have the possibility to support UE without GNSS capability, especially when they are indoor. And also to be more optimized. So the waveform should be more optimized to the specific satellite channel, and especially the satellite power amplifier. We think that we should do something more on the coding to lower the SNS performance. Maybe some adaptation are going to be needed in the framing structure to adapt to the specific of NTN, especially if we want to remove or to reduce the cyclic prefix not required in satellite where we don't have multipath. Okay, we are looking at adding some reference signals for the trusted positioning services, also specific reference burst for the joint communication and sensing. We'd like to support the broadcast and multicast and having enablers for the AI-driven radio resource control to adapt to the fast radio interface or radio conditions. In terms of spectrum sharing or spectrum coexistence between TN and NTN, this is going to require some new methodology to be defined for the specification of RF and RRM, as what is currently being adopted in 3GPP. There are going to be new spectrum allocated, are going to be considered for 6G. So that would require some radio interface impact. And maybe the support of TDD could be of benefit, especially in some bands, which are specially designed for that. So these are the different design drivers of the radio interface. Enhancements to the radio interface. In terms of bands, okay, we have already touched upon. There are two, so FR1, there are going to be new bands allocated up to 7.1 gigahertz as per WRC 2023 outcome. And there is also some bands that are definitely of interest in FR2. We have a standardization approach. This is the timeline we see. So this is the 3GPP timeline for the 6G standard. And in parallel, we have the ITU terrestrial radio interface, which is being developed. And this is tentatively the corresponding ITU IMT 2030 satellite standard. As you see, it started later, but there is a possibility to catch up and be in sync with the terrestrial standard. We do thank your invitation for this workshop, and these are the topics we would like to discuss with other 6G related SNS projects. So use cases and families, the necessary enablers and enhancements for the radio interface and architecture at both RAN and system level. And also we'd like to discuss sustainability metrics and target values for energy consumption and carbon footprint together with other projects. There are different reference scenarios in NTN, all categorized by the type of terminals that are targeted. And this is timeline indication. This is currently for 5G. And this is the timeline indication of the satellite operators that are deploying those infrastructure. Okay, some reference about 6G if you're interested in NTN. And I would like also to take advantage to advertise about the workshop that is going to take place in ETSI on early April about the standardization of the 6G NTN. That's where I can complete my presentation. On behalf of the consortium, I thank for your attention and your invitation to this workshop. Thank you.
Thank you, Nicolas. Just before jumping into the question, I would like also to indicate that we will come back to you with Mao and Miko on the way to continue the interaction, and also especially with respect to this holistic 6G design in Hexa-X-II. In the closing of this workshop this afternoon, we will come back with some concrete proposal on how we would like to further interact with respective to the development of enabler and how we can integrate in this holistic 6G design. But okay, more about that this afternoon at the closing. And then maybe one quick question. What does the interference mitigation require?
I think it's about allocating different chunk of frequency band to the different satellites. So to avoid interference between two adjacent satellites, for instance. So we have to make sure that they're not going to use the same radio resource.